Food industry enzymes, both free and immobilized, are used to recover subproducts, facilitate manufacturing, improve flavor, and stabilize food quality. Immobilized enzyme refers to enzymes physically confined or localized in a certain defined region of space with retention of their catalytic activities and which can be used repeatedly and continuously. Basically, immobilization generates continuous economic operations, automation, high investment, and a high capacity ratio, and also recovery of product with greater purity. Yanasawood et al. 1989 and Mamo and Heses in 1997 suggest that the mobilization of cells generates low levels of enzymatic production compared to free cells due to a diffusional barrier generated by alginate and the reduced availability of oxygen that immobilized aerobic cells can have. Talking about the immobilization methods, enzymes can be immobilized in two ways, using chemical methods and through physical methods, either by absorption on an insoluble matrix and by entrapment with inhales, fibers, or microcapsules. Entrapment is a method that was carried out in this practice. Entrapment is defined as an irreversible method of enzyme immobilization. Entrapment is kegging of enzymes by covalent or not covalent bonds with gels or fibers. Efficient encapsulation has been achieved with alginate gelatin calcium hybrid carriers that prevent the enzyme leakage and provide the increased mechanical stability. Well, to improve performance, enzymes are immobilized by entrapment in different polymer matrices such as calcium alginate, presenting some advantage such as increased productivity, elimination of inhibition caused by high concentration of substrate and product, protection against shear force and friction within the reactors, and the possibility of reusing them with cells in several cycles without the need to recover them. Nonetheless, the practical use of these methods is rather limited as it tends to incur mass transfer, limitation of substrate or analyte to the enzyme active site. Other disadvantages include possibility of enzyme leakage, which can occur when the pores of the support are too large, desactivation during immobilization, low loading capacity, and abrasion of support material during usage.
Types of support. Enzyme immobilization is confinement of enzyme to a phase matrix support, different from the one of substrates and products. Inert polymers and inorganic material are usually used as carrying matrices. An ideal matrix must encompass the following characteristics: inertness, physical strength, stability, regenerability, ability to increase enzyme-specific activity and reduce production inhibition, non-specific absorption, microbial contamination. Hydrocolloids are natural polymers of high molecular weight that can be extracted from different materials, from higher plants, as in the case of galactamines and pectins, from algae such as carrageenans and alginates, from animals from which it is obtained gelatin, and or microorganisms such as sunflower. Polysaccharides are polymers of carbohydrates where the units of sugar are units through glycoside bonds. Each type of natural polysaccharide has an exclusive chemical structure responsible for different insolubilities and texturing effects. The advantage of using polymers from marine algae is the simplicity of the immobilization procedure and the satisfactory result in obtaining small diameter spherical dies which are resistant mechanic appropriate. The certain efforts such as those produced under moderate agitation. Proteins are amino acid polymers. The advantage of use these Biopolymers for the immobilization of the same microorganisms or enzymes lies in the low cost compared to other supports.
Alginate is a term used to describe the salt of alginic acid, and the most common is the sodium alginate. The polymer has gelling power in the presence of the calcium ions, and this depends on the mannuronic acid and hyaluronic acid. The greater or the proportions to hyaluronic acid blocks in the polymer, this stronger and more consistent the gels former will be. The polymer has a gelling power in the presence of calcium ions, and this depends on the mannuronic acid and hyaluronic acid of which it's constituted. The conformation of alginate with calcium ions make up a so-called egg-box model. When a defined concentration of sodium alginate is added to a solution of high concentration of a divalent metal, such as a calcium, and a soluble sodium alginate yield is formed and a jelly process occurs. According to Blandino, the kinetics of the membrane of the alginate bit change with times has shown the following cements. This represents the gelation kinetics. It is a process that depends on the time and the concentration of calcium chloride ions. This affects the kinetics and also the hardness of the beads.
General objectives: immobilize the alpha amylase by the chelation methods with alginate and calcium chloride. Specific objectives: determine the condition for the immobilization for alpha amylase. Methodology: establish a concentration to use of the support. Step 2. In a beaker, put the same milliliters of the enzyme and the sodium concentrate. Step 3. In a beaker, put ice and over this put other beaker with the solution of the enzyme and sodium alginate with and shake with a flash rod. Step 4. With a syringe, drop droppers in the beaker with calcium chloride. Step 5. Wash the dish with a wash bottle as shown in the picture. Step 6. Quantify the total protein by Bradford. Selection of the immobilization condition. Making a comparative table we base on the articles shown in the table 1 in the yellow row. For the reaction of the calcium alginate to occur, the pH cannot be less than 3.5, since the reaction will not occur. The optimum pH for the absorption of alpha amylase is at pH 5. Jose Espinel. Acetatus buffer has a pH range of 3.5 to 5.6, so it was decided to use buffer acetatus at pH 5. According to Consula and Kyriakides, the beads we made had to be very fragile under mechanic pressure and fractured easily. On the other hand, if we would have taken alginate concentration about 3% weight volume, they would be very stiff and difficult to transfer material. For this reason, it was used at concentration of 2.5% weight volume, as Susan mentioned. Operation time in the laboratory is 3 hours, so an article was searched that suited the working time. Airtime managed the condition previously mentioned with a suspension time of 1 hour for the beats. For this reason, we choose this condition of the time for our experiment.
A measurement of the outer diameter of the alginate beads was carried out by taking 10 beads at random, and the diameter was measured with the help of a vernier. Then An average of these measurements was taken, obtaining the results that we can observe on the table. Sosa et al. 2008 found that Bacillus liqueformis and Aspergillus niger with a sodium alginate concentration of 2.5%, the average diameters of the pearls were 4 millimeters. Comparing with our results, we can see that there is a barely variability that was caused by the manipulation of two people at the moment of the formation of the alginate beads.
Bradford test was carried out of the determination of the protein concentration in the calcium chloride, where the beans were formed and the alginate beans. In the following results are observed of the beans of Bacillus subtilis, Aspergillus niger, and the commercial enzyme. Finally, a balance is made of the enzyme recovered according to the initial concentration that was take once, observing a very low percentage or a null percentage of the recovery. These two different factors that affect the test. In your case, to dissolve the alginate beads, they were heated 30 degrees Celsius to prevent the enzyme from becoming desnaturate. However, for the Bradford test, the composite blue dye reacts with adenine basic residues such as histidine and lysine, and with aromatic residues. Therefore, the complement structure of the enzyme is not necessary. This effect this effective factor did not complement dissolve the beads according to the methodology, and the measurements the measurements were not correct. Another important factor to the consider is the blend. According to the kinetic of the helix, time affects the diameter of the external beams, which makes it difficult to dissolve it. The blend was not prepared with the same dress time of the other beams, and the diameter is not the same too, and this also affect to the Bradford test did not perform a cover measurement in the spectrophotometer, obtaining wrong results.
Alpha amylase was immobilized by gelation method and the conditions for immobilization were selected correctly, making a comparison with different reference.